Chapter 15, number 51. To water the yard, you use a hose with a diameter of 3.6 centimeters. Water flows from the hose with a speed of 1.3 meters per second. If you partially block the end of the hose, the effective diameter is now 0.52 centimeters. With what speed does the water spray from the hose? So let's do a really quick sketch. We've got something, and then we're going to restrict it. So I don't know if that's really a good picture for my thumb, and we know this is diameter 1, and this is diameter 2, and the water is flowing with speed v1 here, but then it flows out with speed v2. And the equation of continuity tells us that the density times the velocity times the area is constant, which means we can solve this over and say that v2 is v1 times the ratio of areas. And the ratio of areas for things that are circular is the same as the square of the ratio of their diameters, because the area is pi r squared, and r is just d over 2. So we get something like that. So this lets us put in numbers directly and say we have 1.3 meters per second. Our original diameter was 3.6 centimeters. Our new diameter is 0.52 centimeters, and we're going to square it. Numerically, we get 62.307, actually 308 meters per second, but we have only 2 sig figs, so we end up with really just 62 meters per second.